Because you're not in 5th or 6th grade, I will quickly go over this, but the basic gist that they get at with this little lesson here is that with any fraction, there are a multitude, a host of what we call equivalent fractions. Equivalent fractions, which means, like, if you have the fraction 3/4, you could go on forever and ever and ever writing fractions that mean the same thing as 3/4. For example, 6/8, right? All right, if you multiply the top and bottom both by the same number, you're going to get an equal fraction. I multiply them both by 2, I get this. If I multiply them both by 3, I get with 9/12. If I multiply them both by 4, I get 12/16. These are all equal. If I multiply them by 100, I get 300/400. Anybody know why that works? Caleb, why do you think that works? Let's just say it's based on the identity property of multiplication. What is the, let's talk math. What is the identity property of multiplication? Oh, such a failure. Have we done properties? Have we not done the identity property?
Oh, yeah.
Just nobody wants to answer today. Grace Watson, what's the identity property of multiplication? The identity property of multiplication, Grace, is everybody's just too lazy to go back and look.
Every limit times 1 equals 10.
Yes, anytime you multiply by 1, you get the same thing. Well, look at this. See if you can make this connection. Ready? This is mathematical wizardry. 3/4. Uh-oh. 3/4. Said, oh. 3/4. 3/4 times, here, watch this. Times 1 is going to give you what? Oh boy, it's going to be a long math class. Andrew?
3/4.
3/4. Earth-shattering and groundbreaking, right? Well, ladies and gentlemen, let's take away this 1 that I so lovingly drew in there and make it a fraction that is the same as 1. For example, Madison, give me any fraction that's equal to 1. 4/4. So instead of the 1, I'm going to put something in here that's the same as 1, which is 4/4. Am I still multiplying by 1? Yes, I am. I'm just multiplying by something that doesn't look like a 1, but it is 1. And what do I get when I multiply by 3 times 4? 12. And what do I get when I multiply 4 times 4? 16. That means this fraction, because I just multiplied by 1, has to be the same as the fraction I started with because of the identity property. This is the part where most classes ooh and ah, because that's just the okay. The problem with that is this, children. When you're given a fraction that looks like this, 72/108, this is bad news. Why? Because nobody likes 72/108. Nobody likes to cut things into 108 equal pieces. Okay? Nor do they like taking 72 of them. The problem with this fraction is there are other equal fractions that are easier to understand, and that's what we call, we always want to write the thing in its lowest terms, which means we want the simplest fraction you can use for it, which means back here, where was I? You know, if I was given the fraction 300/400, I want to use 3/4 because that's a lot easier to understand than 300/400. So I've got to figure out how to do that here. How do I do that? We call it reducing, but the book is going to make you do a little extra work here. Be thankful for that. They are going to tell you to reduce, here's today's exceptional thing, by prime factorization. Somebody say yes? Somebody want to say yes?
Yes.
Yes.
Did I spell it right? And you'll remember doing this from last year, I think. Maybe we didn't.
We did.
We didn't? We
Yeah.
did.
We did.
In order to be able to do this, step number one is you have to prime factorize both of them. And now that Ryan has figured out how to do this.
Yep.
Okay. By the way, at some point, I think you can probably speed up this whole process here, but let's do it. If I'm prime factorizing 72, you can do whatever way you want to do, if you want to do the tree thing or whatever. 72 breaks down into 8 times 9, correct? And hopefully by now you know that 8 is what? 2 times 2 times 2, correct? That gives you 8. And 9 is 3 times 3. Anybody need me to go slower on that whole prime factorization of 72? No. Prime factorization of 108, where can I do that? Let's do it right here. If you prime factorize 108, anybody? I guess 2 times 54. 54 is 6 times 9, and 6 is 2 times 3 and 3 times 3. Now this is one you don't want to put exponents because you kind of want to look at these. So on the bottom, 108 equals 2 times 2 times 3 times 3 times 3. Anybody guess what we do from here? Ryan? No, because then I just get 72 over 108. I did this for a reason. It's actually the reverse of the identity property. If there's an identity property that says if you multiply by 1, you get the same thing, guess what happens if you divide by 1? You get the same thing, don't we? So anyways, Cameron's going to say,
you cross off the 2 on the top and the 2 on the bottom, and the 2 on top and the bottom.
because when you put 2 over 2, it's the same as 1, I can get rid of those because it's just like dividing the whole thing by 1. So 1 for 1, you can cross off a 2 for a 2. There's no other 2 on the bottom, so I can't cross off no other 2's, but a 3 and a 3, another 3 and another 3. When you're left, I suppose I should write these rules down. 2, cross off 1 top with 1 bottom. Oh, these people who go on, they don't make me feel good. Cross off 1 top with 1 bottom. I'm left now with a 2 and a 3 left. Okay, step 3, even though we didn't have to, you need to remultiply if needed. Because sometimes you'll end up with 2 numbers left on the bottom, but then you remultiply them. Or what happens if everything crosses off on top? Special case. It's not a 0, sir. If everything crosses off on top, Alex, it's?
A 1.
Right. If everything crosses off on top, you have to leave a 1 up there. If everything crosses off on the bottom, you don't have to worry about it because we can put a 1 on the bottom of something that's just itself. Alright, you ready? I'm going to give you 1 here because I can tell you're not really that sharp. Sure, let's do 36 over 108. And can I tell you, if you already know what the prime factorization of 108 is, you don't have to redo it all over again. We just did 108, so you could just write those numbers down. We already did 108, so there's no point in really doing it all over again. 36, maybe you can get 6 times 6, which is 2 times 3 times 2 times 3, and do all that. Just jot her down, see what you end up. 36 over 108 gives you. Oh, we got a whole lot of stuff here. See, there's just never enough time. It's like all the mathematical wizardry. By the way, today a alone, we did about a week's worth of 6th grade math, one lesson. It would have taken us a week to go through. We did it 45 minutes. David says he got what?
1/3.
1/3. Why? Because on top you should have ended up with 2 times 2 times 3 times 3, correct? On the bottom you did that 2 times 54, which was what? 2 times 2 times 3 times 3 times 3?
Yes.
So then 2 2s, 2 2s, a 3, a 3. Everything crossed off on top, you can't just put nothing up there. There's always going to be a 1 up there. You get 1/3. Like I said, if you'd ended up with a 3 on the top and a 1 on the bottom, same thing, except we don't write through them, we just say it's 3. Yep, good. All right. Forging ahead, how about this? 2/3 or 3/5. If you're comparing these two fractions, because you're smart, I'm going to give this to you. By the way, people, no longer will you draw pictures. Okay, this is not about drawing 2 circles and shading them anymore. That was 5th and 6th grade stuff. 7th and 8th grade, we get a little bit more scientific than that. How do I know which one is bigger or smaller without drawing pictures? Logan?
You gotta make them have the same term.
Okay, I'm going to tell you yes, that's true, and then I'm going to tell you you can do it a lot faster than that. But we're going to do this first. What's the common denominator between 3 and 5? The smallest thing that goes into both of them is 15. 3 times 5 is 15, so 2 times 5 is 10. 5 times 3 is 15. 3 times 3 is 9. Which one is bigger? 10 15s. Now, I'm only going to tell you this because I'm not a big believer in this, but I'm going to let you do it because you're relatively intelligent. A quick way to do this, kids, is just this. Matt's going to work with me here. Take the bottom, multiply by the top. 5 times 2 is 10. Put that 10 over there. Take the bottom, multiply by the top. You get a 9, and bam, you're done. 10 is bigger than 9. Because really what you've done is the same thing as this. You just didn't write the 15s on the bottom. Let me give you another one. What if it was 17 over 20 compared to, I don't know, well, I guess I could do 8/9. 17 over 20 compared to 8/9. Well, this one's easy. 20 times 8 is 160. 9 times 17, you might have to go off to the side a little bit. You get what? 153. Which one's bigger? 160. You just didn't put the 180 on the bottom. And how about this? They'll also give you this. 3 over 5 equals what number over 20? Oh, now we're twisting each out here. How do you do this one here? Going once, going twice. Brooke Collin. Yeah, or I just say, yeah, you could say 5 times what is 20? So whatever you do to the bottom, you do to the top. 3 times 4 is, really what you're doing there again, look at, it's that whole identity property. It's 4, you're multiplying by 4 over 4, which is 1, which gives you the same fraction. Please don't then say, do I have to reduce this? No, they're looking for that number there, so don't make it bigger and then reduce it, because that's what they're asking for. Sorry, we had to